What's up, guys? So we keep solving the Math GRE subject test, GRE form 19768, 60 and 59. Then A be a real 3x3 matrix. Which of following condition does not imply A is invertible? Okay, to solve this, we need to know some basic fact. So fact A is invertible if and only if determinant A is non-zero. Also, determinant A is the product of all eigenvalues. So you tell you there's all eigenvalue must be non-zero, and also tell you that the rank A should be as same as the dimension of the vector space, or the n, or it should be 4 rank. And all these are if and only if condition. So we have some 3-4 facts that which are equivalent and that we can use. Okay, the first one, minus A is invertible. I mean, this is stupid. Because it's obvious that the answer is correct. Minus A is invertible, so determine minus A is non-zero, and determine minus A is just minus determine A is non-zero, so determine A is non-zero. So this A is correct. B, there is the positive integer that determine AK, and so all you need to know is determine AB is determine A, determine B. So determine AK, just determine A to the K. This is non-zero, so that means that each the determine A is non-zero. So we have the same results. So A, B are exactly the OK choice. How about C? There it is the positive integer such that I minus AK is equal to 0. So this is basically the same problem, the same fact that I mentioned. If I let M equals I minus A, and Fk is 0. This tells you that all the eigenvalue of M is 0. This is called the nilpotent matrix. Basically, this is if and only if. Okay, but all eigenvalue of M is 0. This tells you that all the eigenvalue of A is 1. Since all the eigenvalue of A is non-zero, we know that A is invertible, since the determinant of A is just product of eigenvalues, and none of eigenvalues is 0. So determine A non-zero, A is invertible. So C is correct. How about D? In D and it tells you that image A is the dimension of image A is 3. The set of all vectors of the form AV, yeah. Where V equal is in R3. What? The set of all the vectors of form AV. Oh, it's R3. So basically, yeah, dimension image A is 3. So basically, it tells you that A is 4 rank. Or you can use the dimensionality theorem that dimension kernel tell you that dimension kernel A is 0. So that means kernel A only contains 0. And then they tell you that AX equals 0 only has X equals 0 solution. And then this tells you that A is invertible. So this is correct. And that's E. So the answer must be E, right? Because we already cancel A, B, C, D. So there is these 3 linear independent vectors, such that all of them are the image are non-zero. And in order to show this, I need to come up with some counterexample. But basically, you can see that suppose you have x, y, z, you have some linear independent vector. And you just need to come up with a map, which it can be non-zero. 3 of them must be non-zero, but it only contains like the dimension 2 or dimension 1 region, so that A is non-invertible. So basically, the easy way is maybe I can write A is 1 1 0 0 1 0 0 0 0. So basically, A just projection the first 2 dimensions. I choose V1 to be 1 0 0, and the V2 to be 0 1 0. So AV1 is 1 0 0, AV2 is 0 1 0. But any vector combination of A and X, X and Z, or the Y and Z, the projection is still non-zero. So I can choose like V3 equal to 1 0 1 or any other vector, and so AV3 is 1 0 0. So AV3 is non-zero, but V3 is exactly V3 cannot written as a linear combination of V1 and V2 because the third component is always 0. So the answer is E.